No.
Good morning, students.
Good morning, sir.
Yeah. Can you both have your videos on? Yeah. So good morning, both of you. Any idea about Raghav? Is he joining?
I don't know, sir.
Not sure? Okay. So 1 minute. I'll ask my team to check and then I'll get back. Just give me a minute. Yeah. So good morning, guys. I think Raghav has also joined. Okay. So shall we get started? Yeah. So ready to get started?
Yes, sir.
Okay. So last class we started with vectors, right?
Yeah.
So can you tell me what was the last concept we discussed? I remember introducing the concept of vectors and scalars. Then
Magnitude of the vector and unit vector. And
So we did unit vector and direction of unit vector.
I introduced how the mathematics is calculated. Yeah. So direction of vector. Right. So is my voice breaking or is it continuous? You're fine. My voice is continuous, right? Is it breaking?
no, sir.
Okay. Okay. So I think we have already seen this. So geometrical definition. So basically, how did I say a what did I say a vector is? Vector is basically a directed line segment. Means if you take a line segment where it has a direction associated, you can call that as a vector quantity. Then how do you represent it as a vector? You write it as capital AB with a bar on top of it. How do you read it as? You read it as AB vector. So if you use the starting point and the ending point, you write in the caps. Whereas if you give a name to the vector, if you call that as small a, for instance, then how do you write it as? You write it as small a with a bar on top of it. I hope this clarity is there, right? This point I have already discussed, right? The next important point is we need to understand the magnitude of a vector and how is the magnitude represented. So if you write AB with a bar on top of it, it is going to be the vector form. Around this, if you put a modulus, it becomes magnitude of AB vector, right? Or else, how will you write a line segment? If I ask you to say, let's say I'm teaching you geometry and ask you to draw a line segment AB of length 5 centimeter, then how will you write? You will write AB is equal to 5 centimeter, right? Then this AB is also called as magnitude. So that is why we can either represent it with the help of a modulus. So when you put an arrow mark on top of it and put a modulus, it is going to be magnitude. Or if you remove the arrow mark and just write it AB also, the people will be able to understand that you're talking about the magnitude of a vector. Am I clear with this? Right. So whenever you need to compare two vectors, if I ask you to compare two vectors, if somebody tells you that AB vector is greater than CA vector, this does not make sense, because two vectors cannot be compared along with the magnitude and direction. They can be compared only in terms of their magnitudes. You can make a note of this point also. So two vectors can be compared only in terms of their magnitude. So AB vector is greater than CA vector does not make sense. Rather, magnitude of AB vector is greater than magnitude of CA vector makes sense, right? I hope that point is registered.
Yes, sir.
Okay, shall I proceed? Shall I?
Yes, sir.
Next. So this is another important point which I want you to make a note of. See, this already I've explained it, but I'm just revising it again. So when I talk about the important points related to a vector, every vector, whenever you speak about a vector, right, it has two important characteristics. What are they? One is magnitude and the second is direction, right? So it has to be direct and it needs to have a length associated with it. So that's what this point is. And about sense, what do you mean by sense? Sense is, for example, if I have to write AB vector, if I write
Sir,
AB,
your voice is breaking.
is it breaking? Okay, okay. I repeated. So I hope this point has got registered. Every vector has two characteristics. What are they? One is length and the second is direction. Right? The direction is given a name called as sense. Suppose I want to tell somebody that I'm talking about AB vector. So if I write something like this, the person who's seeing your paper will understand that you're trying to speak about a directed line segment whose starting point is A and the ending point is B. Whereas if I write BA vector, see, though the letters I've used is the same, they both don't mean the same in terms of context. Because whenever you're writing a vector, you should always ensure that you're writing the starting point on the left and the ending point on the right, and you put a vector symbol on top of it. This is a very, very, very important condition to be followed. Am I clear with this? If you swap it, you're done. Because slowly we'll be learning about this concept. AB vector is equal to BA vector is wrong. Rather, it is negative of BA vector. It's called as negative of BA vector. Why that negative sign is coming is because the directions are exactly opposite to each other. Okay. So now we will see about the different types of vectors. See, when I explained about the magnitude, I introduced the concept of orthogonal unit vectors and unit vectors also. Did I? So just look at your notes and tell me what a unit vector is basically. A unit vector is a vector whose magnitude is
One.
So it can be one unit. It can be anything, 1 centimeter, 1 millimeter, 1 micrometer. It will be one. Right? How is a unit vector represented as? You give the name to that vector and you put a cap on top of it. So what is the other name? You either call it as a cap or you call it as hat also. So you call it as cap or hat. Right? So this is one thing. Now, if I give you a vector A, so A with a bar on top of it is A vector. If I ask you to find the unit vector in the direction of A vector, what will you do? A cap is equal to A cap
So
is
A
equal
vector by magnitude of the
to
vector.
A vector divided by the mag A, right? This is the thing we have solved in the previous class. All right. So that was the last thing, right? Okay. Now we shall discuss the different types of vectors. When I talk about the different types of vectors, we have equal vectors, we have parallel vectors, anti-parallel vectors, negative vectors, collinear vectors, zero vectors, something like this. Right. So whenever you classify something, right? Whenever you classify, when I say classification, you talk about the different types of something. So there needs to be a differentiating factor. So here, when I talk about the types of vectors, in terms of magnitude and direction, based on these two parameters, I can classify the vectors into different types, of which the first one is called as equal vectors. So as the name suggests very clearly, equal means, so whenever I speak about the equality of two vectors, they need to be the same in terms of
magnitude.
and magnitude. Right. So if I give you two vectors and ask you to find whether they are equal vectors or not, what kind of a test will you run? You will see whether both the vectors are in the same direction.
Direction and magnitude.
If the length of both the vectors is same, then you can say they are equal vectors, right? Vectors of same magnitude and direction. Okay, that is what the theoretical part is. But how are we going to write it mathematically? So if I give you a vector like this, which I'll call it as AB, then what do I call this as? This is going to be AB vector. If I give you another vector CD, then I'll call this as CD vector. Then I can say AB vector is equal to CD vector, provided their directions are same and the magnitude is same. Am I right? Yes. Okay. Next is set of parallel vectors. So vectors in the same direction, right? If I have vectors in the same direction, but unlike equal vectors, the point is here, the magnitude need not be the same. You're able to understand. See, for example, if I have this as AB vector, and if I have this as CD vector, if one vector is scalar times the other vector, AB vector is equal to K times CD vector, then you can say that these two vectors are parallel to each other. Okay. Now here comes an important question. Are equal vectors parallel vectors? Are all equal vectors parallel vectors?
Yes.
Yes, sir.
But are all parallel vectors equal vectors?
No.
No, sir.
That is the meaning, right? Next. So the next one is anti-parallel vector. The name itself suggests, right? Anti-parallel vectors means vectors which are in opposite directions. See, one common mistake that happens is I've seen students referring it as vectors which are in different directions. Different direction is wrong. Anti-parallel means they should be exactly in the opposite direction. Means one vector is like this, the other will be like this. So going forward, right, whenever I show my finger, the nail side is the arrow mark. Okay, have it in your mind like this. So this AB vector, this CD vector, if they both are in opposite directions, then you call them to be the anti-parallel vectors. Right? Similarly, in the case of anti-parallel vectors also, what will happen is one vector will be scalar times the other. In terms of magnitude, one vector will be scalar times the other, but the direction will be opposite.
Sir, you told like A, B, and BA, right? So they are anti-parallel vectors.
AB and
BA. AB vector and BA vector.
they will be anti-parallel. Okay. Then we talk about negative vector. So negative vectors are vectors which are in opposite direction and have the same magnitude. So if this is AB vector and this is CD vector, AB vector is equal to negative of CD vector. So AB vector is equal to negative of CD vector. Am I clear with this?
So negative vectors can be anti-parallel vectors and anti-parallel vectors may not be negative.
Need not be negative. It's the same like how equal and parallels work. Right? Next. What is a collinear vector? What is a collinear vector? So, vectors which are lying along the same line are called to be collinear vectors. So basically what happens is collinear vectors and parallel vectors tend to come out to be the same. Unlike the points, when I say collinear points, right, you say that the points lie on the same line. Unlike them, when you talk about parallel vectors or collinear vectors, they are same. For example, one vector can be like this. Because when I told you the equal vector, they have the same magnitude. Drew it identical vectors, which can meet. Can I call these
Sir, your voice is
vectors to be equal vectors? 1 minute. I've drawn it. Let me change my network one. So if I draw AB vector and CD vector like this, can I call them to be equal vectors, this part?
Yes.
Yes, they are. Because we told they should have the same magnitude and same direction. That's it, right? Now, these vectors turn out to be collinear vectors also. So there is AB vector, and let's say this is CD vector. Then I can write AB vector is equal to some k times CD vector, where k is a scalar quantity. So to put it simple, right, in terms of vectors language, parallelism and collinearity mean the same. Why I'm telling this point is, in some of the problem, they'll ask you to check whether the given vectors are collinear or not. So if you check the condition for parallelism or collinearity, you will get the same answer. Okay. Next, what is a zero vector? Name suggests again. What is a zero vector?
Null vector.
The null vector, basically a vector which has no magnitude and obviously no direction. Right. So I'm not discussing the properties and all as of now. Right. Then I've completed what is a unit vector. I've completed what is an orthogonal unit vector. Now, see, these things are for higher studies. It's not needed as of now. So the next one I'm going to explain is something which is very important again, which is called as position vector. You've heard of this term? Have you heard this term called as position vector?
I've heard, but I don't know what it is.
Okay. So we have seen parallel and opposite vectors, anti-parallel vectors, coplanar, unit vector. We saw what are orthogonal unit vectors. So here comes the next concept, that is position vector. So it is very, very, very important. I repeat it, it is very, very important because you'll be learning the parallelogram law of vectors and everything, right? There I'll be using these terms. And one more thing that you can have in your mind is, since I told this chapter actually doesn't fall completely under physics, except the physical quantities that you're using, every other operation that you're using is actually mathematics. That's why it's called as vector algebra. Okay, which you learn the same things again in your 12th grade mathematics, 10th chapter of your textbook. Okay, you learn the same things. Okay, so what I'm trying to say is, since it falls under mathematics, there are different branches of mathematics that can be connected to vectors, among which one of the important branches of mathematics is coordinate geometry. This you would have understood when I explained the orthogonal unit vectors itself. I took a point and then explained it, right? So when you take a point P 2, 3, for example, I'm explaining with 2 dimension. You can extend the same to a 3-dimensional space also. Only thing is the third coordinate will get added as well. Okay, so 2, 3, let's say there is a point in the plane. For the 2, 3, I can take any point as a reference. Meaning, I could have started from here and I told I reached this point 2, 3. I could have taken this point and told I have reached this 2, 3. But what we are going to observe is what is the meaning of the 2, 3 in this context? In this context, it means from here if I drop a perpendicular, right? The distance from the origin to the foot of the perpendicular is going to be 2 units. And the distance, if I drop a perpendicular from here, the distance from the origin to this foot of the perpendicular is going to be 3 units. Makes sense? So this P2, 3, when I take the initial point to be origin, then I can draw a vector like this. And what will be the name given to this vector? You will call it as O, starting point, P, ending point with a bar on top of it. You read it as OP vector. Means if the initial point of any vector is considered to be origin. I repeat it. If the initial point of any vector is considered to be origin, then that vector is said to be the position vector. Because you are defining the position of that point with respect to origin. Am I clear? So I want this point to get registered. Is it clear? So OP vector is called as position vector of point P. So you say, whenever you say position vector, right, you say, this is the language you use, position vector of a point. Okay, position vector of a point, right, with respect to origin. So position vectors are those vectors whose initial point is origin. Am I clear with this? Right? So as of now, have this in your mind. Now I'm going to get into the mathematical operations of these vectors. Shall I proceed? Okay. So when I talk about the basic mathematical operations, right, like how you perform the operations in vector in algebra, right? So if I give you a linear equation in two variables, 5x plus 3y is equal to 2, and I give you 3x minus 2y is equal to 5. Right? These are two linear equations in two variables. If I ask you to add them, what will you do? You will add the coefficients of the x and you will add the coefficients of y and you will add the constants. So what is the answer for this going to be? It is going to be 8x plus y is equal to 7. It's very simple. So what is it? It is 8x plus y is equal to 7. All right. Now, the only difference between algebra and vectors is in algebra you use x and y. In vectors you use I cap, j cap, and k cap. Right. So if I convert this to a vector form, only thing is you will not have the constant also. You will not have something like this. You will not have 2. So if I convert this to the vector form, can I say a vector is equal to I cap plus 3j cap plus 4k cap. I take some random vector and I take b vector is equal to minus I cap plus j cap. Then if I ask you to do an operation of a vector plus b vector, what will you do? You will take the first vector I cap plus 3j cap plus k cap plus minus I cap plus j cap. You're going to add them. So what are you going to add? You're going to add the coefficients. So I cap and I cap will get cancelled. You will have 0 I cap. 3 plus 1, 4j cap. So k cap has no coefficient here. Here, what is the meaning? It is 0 k cap actually. So 1 is getting added to 0. So you're left out with k cap. So the result is going to be 4j cap plus k cap. It's very simple. Right. See, listen, why I'm stressing again is here I'm discussing about addition of vectors, but there are two more concepts where we'll be discussing about something called as triangle law of addition of vectors and parallelogram law of addition of vectors. So try to understand the difference. So whenever somebody says only addition of vectors, they'll give you the vectors and you just need to add them. That's it. Okay. See, though it is simple, right? I would suggest you to write it for the sake of practice. Please write it down. Shall I proceed? So the next concept is subtraction of vectors. I take these two vectors, I'm going to subtract them. So it's basically like a vector minus b vector. So a vector is I cap plus 3j cap plus k cap minus b vector is minus I cap plus j cap. So I cap, this minus of minus I cap is going to give us plus I cap, and minus of, so minus into plus is going to give us minus. So what is going to be the answer? 2I cap plus 2j cap plus k cap. Right? Simple, no?
Yes, sir.
It's very simple. Now we will see the concept of multiplication of vectors. So when I talk about multiplication of vectors, basically there are two types of multiplication. One is called as dot product and the second is called as cross product. Basically, it is not like algebraic multiplication where you will have numbers 2 into 3 and you're going to give it 6, or 2 into minus 3 is going to give you minus 6. Not like that. So you will have, for example, a vector as I cap plus j cap and b vector as I cap minus j cap. Then you'll be performing two kinds of operations. What are they? One is called as dot product, or it is also called as scalar product. And the second is you have something called as cross product, which is also called as vector product, about which I'll be teaching you later. Okay. So having said this, if I have to look at the, sorry, if I have to look at the next mathematical operation, what do we have? We need to have something called as division of vectors, but remember, vectors cannot be divided. There is no concept of division of vectors at all. It does not exist. So with this, we are entering into the important laws of vectors, which are also called as the addition laws. All right. So now I'm going to explain you the important concept, that is laws of vectors, which is also called as the addition laws of vectors. Right. In which one of the laws is called as the triangle law of addition, and the second is called as the parallelogram law of vectors. What are they called as? It's called triangle law of addition or parallelogram law of vectors. So shall I proceed? So listen to this carefully. Okay. See, when I speak about triangle law, right, when I speak about either triangle law of addition or parallelogram law of addition, you will be given two vectors. So you should know when to use which one. Okay. So first, let's concentrate on understanding what these triangle law of vectors are. So as the name suggests, triangle, right? So for me to form a triangle, I need three sides. But what did I tell you? For you to perform the operation, they'll give you only two vectors. So with two vectors, you can form only two sides. Then what is the third side going to represent is what the question is. Okay. Now listen to this. If two vectors which are given to us are represented in magnitude and direction by two adjacent sides of a triangle, if you take them to be as two adjacent sides of a triangle, but an important point to be kept in mind is adjacent sides of a triangle taken in order. I'll tell you what is the meaning of that. If they are taken in order, then the resultant of these two, what do I mean by resultant is, see, for example, this is one vector. Okay, this is one vector, I cap plus 3j cap plus 4, k cap is one vector, and minus I cap plus j cap is another vector. Then when you do a plus b, right, you're getting some output. No, this one 4j cap plus k cap. This is called as the resultant. Okay. Suppose the two vectors that are given to us are represented in magnitude and direction by the two adjacent sides of a triangle taken in order, then the resultant of these two vectors is given by the closing side of the triangle, that is the third side of the triangle, taken in the reverse order. Taken in the reverse order, which is equal to the sum of the vectors taken in the order. Okay, let me explain this statement. Okay. So, if I give you two vectors A and B, if I take A vector and B vector like this, so if this is A vector, right, and this is B vector, observe this. Now, if you see A vector and B vector, right, they are said to be in order. Why did I say they are in order? Because the ending point of the first vector is acting as the starting point of the second vector. So they both are said to be in order.
Sir,
so when
they give a question, will they mark the arrows?
sorry,
If they give a question with a triangle, will they mark the arrows?
you have to take it. That depends on the question. That depends on the question. Okay, but here we are only seeing the law. I'll tell you when to apply which one when we see problems. You'll have better clarity. But this point is what I want you to concentrate on, because parallelogram law of vectors is almost similar. That is where I've seen many of them getting confused. They don't know, even in 12th standard, if you ask your seniors, right, most of them don't know where to use triangle and where to use parallelogram, because they miss this basic. Okay, so I don't want you to miss that. Listen to this. So if A vector and B vector are taken in such a way that the ending point of the first vector is the starting point of the second vector, then those two vectors are said to be in order. So here A vector and B vector are said to be in order. So that's what the first part of the statement says. If you take those two vectors in order, then what does the remaining part of the statement say? Then the closing side of the triangle. So with just A vector and B vector, I have not completed the triangle. I need to close it. So the closing side of the triangle will be the resultant of these two. But how should you take the closing side of the triangle? You should take the closing side of the triangle in the reverse order. So what do I mean by reverse order is, you need to take the starting point of the first vector and
Ending point.
join it to the ending point of the second vector. If you do that right, then this will become the closing side of the triangle exactly in the reverse order. Why is it in the reverse order? Because had C vector been in order, then what should have happened? The ending point of B vector should have been the starting point of C vector. That didn't happen. See, look at the diagram. The ending point of B vector is not the starting point of C vector. Hence, they are not in order. They are in the reverse order. So, what happens here is, mathematically you can write that the closing triangle, that is C vector, is equal to A vector plus B vector. This is the mathematical expression for law of addition. Am I clear with this? Are you clear with the statement? So,
Can you repeat? Can you go up, sir? I have to copy.
yeah, you can copy it, but I'm just telling you. Is it clear? The
Yes.
concept is good. I'll give you time to copy.
Oh,
Yeah. So here I mentioned, see, head of the first vector should be the tail of the second vector. That is the meaning. That is where you say they are in order. If it fails, it is going to be in the reverse order. So going forward, I'll not explain this in detail. I'll ask you only one question: whether the vectors are in order or in reverse order, you have to tell. Right? So having said this, make a note of the statement and write down the mathematical part. Let me know once you're done. Shall I proceed?
Yes, sir. Sir, so this the statement of the triangle of addition. The paragraph. Okay. So if they ask, write the statement of triangle of the addition, you have to write it fully.
This is what you need to write.
Okay.
So when you read this, the most important points you need to underline are two things. One is in order, and the second is reverse order. If you don't mention them, it doesn't make sense of which law of addition you are speaking about.
Okay.
You'll understand the difference after I explain parallelogram.
Okay.
So for this, there is no mathematical part or something. There's just C vector is equal to A vector plus B vector. That's it. Okay. The next important thing that we are going to see is parallelogram law of vectors. So like how I told you, right, whenever you speak about the different laws of vectors, here you are going to speak about the addition of vectors. They can either be triangle law of addition or parallelogram law of addition. So for triangle law of addition, you take the two vectors to be in order, whereas here in parallelogram law of vectors, we will have two co-initial vectors. So if two co-initial vectors are represented in magnitude and direction by two adjacent sides of a parallelogram, then who is going to give you the resultant here? The resultant is given by the diagonal that is passing through the common tail of the given vectors. So meaning of it is, if I give you two co-initial vectors, so co-initial means they have the same starting point, unlike order. In order, what happens? Ending point of one is the starting point of the other. Whereas in this case, starting point of both is the same. We don't know about the ending points. So if I give you two co-initial vectors, which are going to be taken along the two sides of a parallelogram, if you take them to be the two adjacent sides of a parallelogram, then the resultant is given by the diagonal of this parallelogram. See, of course, you might ask a question, sir, with two vectors, how is a parallelogram completed? We need to complete it. I'll show you how to do that. So if two co-initial vectors are given, then the resultant of this is given by the diagonal of this parallelogram, which is starting from the common tail of these two. Are you able to understand? So that is meaning. Then the resultant is given by the diagonal passing through the common tail of the given vectors. Okay, first write down the statement.
Sir, I can't hear you.
Are you able to hear now?
Yes.
Now am I audible? 1 minute. Am I audible now?
Yes, sir.
Okay. So if I take
Sir, I can't hear you.
am I audible now?
Yes,
Is it
sir.
better?
Yep.
Okay. Okay. So now in order to complete a parallelogram, what I'm going to do is I'm going to consider a vector which is I'm going to consider an equal vector to B. So equal vector to B means has the same magnitude and same direction. So if I draw it like this, can I call this also as B vector? Similarly, I'm going to construct a vector which is parallel to A and of same magnitude, which I can call it as A vector. Now, what are the two given vectors? A vector and B vector are given, but using them, we completed a parallelogram in such a way that the resultant is given by the diagonal that is passing through the common tail of both, which is going to be C vector, for instance. Right. So, if I cover the top part of the triangle, suppose I cover this part of the triangle. I mean, if I cover the top part of the parallelogram, right? If I cover this part of the parallelogram, then is the bottom not looking similar to that of a triangle law?
Triangle, yes, sir. A and B are not.
A and B are in order, and C is the closing side of the triangle taken in the reverse order. That is why parallelogram law vectors and triangle law vectors are actually the same. They are actually the same. Only thing is, depending on the context we are going to apply. So if at all the given vectors are going to be co-initial vectors, you'll use parallelogram. If the given vectors are continuous vectors, in the sense if they are in order, you use the triangle law. But both will generate the same result. Both will generate the same result. I hope I'm clear.
Sir.
Okay. Now, if I take the angle between A vector and B vector to be theta, right? Suppose I extend this line, then how much is this angle going to be? That will also be theta, because they are corresponding angles. So from here, if I drop a perpendicular, right? If I drop a perpendicular, now I'm going to complete this A, B, C, D, E. So I've just labeled them, right? So the reason why I dropped the perpendicular is because I have angle, and whenever angles and distances are involved, we need to use trigonometry. So for us to use trigonometry, we need a right angle triangle. That is why I dropped the perpendicular. Am I clear with that? See, now I call this as B vector. No. What is going to be the magnitude of BD? It is just B. I told you, no? For the given symbol, if you remove the vector symbol on top of it, it becomes the magnitude. Am I right? Now, what I'm going to do is, see, I will consider the right angle triangle DCA of the triangles, and I'll consider the other triangle, which is DCB, which is going to be theta here. Right? This is going to be B. Then how much is this going to be? If I take this to be X, then X divided by B is equal to cos theta, which implies X is equal to B cos theta. Similarly, if I take this to be Y divided by B is sin theta, which implies Y is equal to B sin theta. So this distance is going to be B cos theta, and this distance is going to be B sin theta. Hope I'm clear.
Can you repeat it one more time?
Which point?
After taking the triangles ADC and
I took
BD.
this as X.
Okay.
X divided by B is cos theta. Adjacent by hypotenuse is cos theta.
Yes, sir.
So X is equal to B cos theta. Similarly, I took CD as Y. Y divided by B, opposite by adjacent, sorry, opposite by hypotenuse is going to be sin theta. So Y by B is sin theta, Y is equal to B sin theta. Okay. Now I'm going to take this value and plug it into the bigger triangle. This is B sin theta. Now observe what is AC. AC is basically AB plus BC. AB is A.
Okay.
BC is B cos theta. So
Cos.
how much is this length going to be? It is going to be A plus B cos theta. Makes sense?
Yes.
And AD is going to be C.
Okay.
Right? So what can I write? I can write AD square is equal to AC square plus CD square. AD square is equal to AC square plus CD square. What is AC square? It is A plus B cos theta the whole square plus what is CD square? It is B sin theta the whole square. So what will you get? You will get A square plus B square cos square theta plus 2AB cos theta plus B square sin square theta. So B square cos square theta plus B square sin square theta is going to be B square. Because if I take out B square common, I'll have cos square theta plus sin square theta inside. So which is going to be
1.
1. So that is why it is A square plus B square plus 2ab cos theta, which is going to be AD square, which is C square, where C is the resultant. Remember, the resultant is given by the diagonal, which is passing through the common tail of both the vectors. So what is going to be the value of C? It will be root of A square plus B square plus 2 times AB cos theta. So this is going to be the value of the resultant in terms of A, B, and the angle between them. Am I clear with this? Am I clear with this or not? Right? So this is one thing. Let me complete it. Sometimes what happens is they'll ask you, what is the direction of the resultant? Listen to this carefully. What is the direction of the resultant? So when they say direction, they are not asking about north, east, west, south, something like that. Direction in terms of vectors means angle made by the resultant with any one of the vectors. So here I've taken alpha to be the angle made by C vector, that is resultant with which vector? With A vector. Am I right? So if I take the bigger triangle here, is this not going to be alpha? Right. Then what is going to be tan alpha from this triangle? I'll write it here itself. Tan
B
alpha is,
sin B sin theta by A plus A
it is
plus
going to be B sin theta divided by A plus B cos theta. Right. This is tan alpha. But whenever they ask you the answer, right, for the direction, you should write alpha is equal to tan inverse of, let me call this value as capital X. So tan inverse of that B sin theta divided by A plus B cos theta. So about this tan inverse, you'll learn later. As of now, don't worry. Basically, direction means you need to find the angle made by the resultant with any one of the vectors. Okay. So make a note of these points. I'll tell you how to use it. Right. So write it down. Let me know once you're done writing.
Sir, can you scroll down? Sir, can you go?
Let me know once you're done.
Sir, I have a doubt.
Tell me.
Sir, if we take like tan alpha is equal to B,
Your voice broke. Tan alpha is equal to 1 minute. 1 minute. Tan alpha is equal to what did you say?
no sir, B we can do like B sin theta by A plus tan
Cos
theta.
theta. A plus B cos theta.
Sir,
B sin theta divided by
B sin theta by A plus tan theta can be.
Like how will you split the denominator plus in the denominator?
Okay.
You're saying B sin theta by A plus you will write it as B sin theta by B cos theta. Cancel this and you'll write tan theta. But how can you split the terms in the denominator?
Okay.
See, for example, I have 1 divided by 2 plus 3. Is it the same as half plus 1 by 3?
No. Okay.
You can split it only when you have multiplication 1 by 2 into 1 by 3. That you can. Okay, this is wrong. So, not valid. Right? So, this is all about the parallelogram law of vectors. The next set of concepts that we need to discuss is about the dot product of vectors. Right, now we'll go to the product of vectors. So when I talk about the product of vectors, I told two products. What are they? One is dot product, which is also known as scalar product. Then you have cross product, which is also dot. Yes, dot or scalar product of two vectors is what we are going to discuss now. So write down the heading as dot or scalar product of two vectors. So if I give you two vectors, A vector and B vector, then if you perform an operation like A vector, you will put a dot between them. If you write A vector dot B vector, right? This is read as A vector dot B vector. Then it is going to be magnitude of A vector times magnitude of B vector times cos of the angle between them. So that is the definition. Magnitude of A vector into magnitude of B vector. So magnitude of A is a scalar, it's a number. Magnitude of B is a number into cos of the angle between them, that is also a number. So a number multiplied with a number is going to give us a scalar. That is the reason why dot product is also called a scalar product. So you should not confuse that dot product means it is done between scalars. No, dot product is done between vectors only, but the output is going to be a scalar. That is why it is called as scalar product of two vectors. Am I clear with this? Right? Now, see, suppose I take a vector like this, A vector, and if I take another vector like this, which is B vector, right? And if I am asked to find the angle between them, okay, I'll come to this point next. Listen to this. So how will you have a geometrical interpretation of what is the meaning of this? Suppose I have one vector like this. This is A vector. And suppose I call this as B vector. Right? Then if the angle between them is considered to be theta, for instance, then A vector dot B vector means it is A into B into cos theta, right? That's accepted. So what we are doing is, you're able to see that A is making an angle with B. So B vector is longer in the diagram that I've considered. So from the end of A vector, if you drop a perpendicular, listen to this carefully. When I drop a perpendicular, then from the bigger part of B, can I say this A cos theta is going to be a part of it? Right? How did I get that A cos theta? Because if I take this distance between, let's say, O to point P is X, then what is X divided by A? What is X divided by A?
Cos theta.
X divided by A is cos theta. Then what is X? A cos theta. It's something that we did in the parallelogram law of vectors. So this OP, is it not a part of the B vector? B vector is big, OP is something like this. So A cos theta multiplied with the length of B is also going to be the output of dot product of A vector and B vector. See, there's another way of understanding. You're able to understand what I'm saying. So when you drop this perpendicular, right, you're getting the distance OP, right? The distance OP is given a name called as projection of A along B vector. Means from A, you drop the perpendicular, you measure the distance between the starting point and the foot of the perpendicular. That is called as projection of A vector along B vector. This word projection is used very less in physics, but you learn about this more in detail in your 12th standard. Are you able to see what I'm trying to say? It's actually a very simple concept.
Sir, I don't get what projection is.
Projection means from one vector you drop a perpendicular onto the other vector. See, from A, I dropped a perpendicular onto B, then I got the foot of the perpendicular here. I have the initial point here. The distance between those two is what is called as projection. Okay. Sometimes what will happen is, see here you are able to define the angle between the vectors. Sometimes what will happen is you will have diagrams of this sort. So if I take this to be A vector, and if I take this to be B vector, and if I ask you to find the angle between A vector and B vector, right? If at all you take this to be the angle theta and substitute it here, substitute it in this place, then you're wrong. So what you need to do is,
Sir, 180 minus.
no, 180 minus, or what you need to do is extend this A vector and then find the angle between it. That is theta. So you're able to understand the difference between this diagram and this diagram. What is the difference? In the leftward diagram, I have the vectors to be coinitial vectors. Whereas in the right side, I have them to be continuous vectors. So whenever you have continuous vectors, you need to extend the bottom vector and then find the angle on the other side. Whenever you have coinitial vectors, just find the angle between both. This is very, very important when you're going to solve problems. Am I clear with this? Clear, right? Make a note of this.
Thanks.
Done. So we'll see the properties of dot product. First thing, dot product is commutative in nature. That is, if you do A dot B or B dot A, they are going to give you the same result. So A vector dot B vector is the same as B vector dot A vector. Second is dot product is distributive with respect to its sum, meaning A vector dot B vector plus C vector is the same as A dot B plus A dot C. The same is applicable even for minus, because A is getting distributed to both the terms within the bracket. So it's called as distributive law. Suppose if the two vectors given to us are parallel or collinear, then A vector dot B vector is going to be equal to AB times cos 0 degrees, which is also written as AB. So you'll just do the dot product between both and leave. If suppose the angle between the vectors is 180 degrees, if they are anti-parallel to each other, then A dot B is going to be equal to AB times cos 180, which is going to be negative of AB. I'm not sure if you know the value of cos 180. Cos 180 is minus 1. You know this? Do you know that cos 180 is minus 1?
Yes, sir. Yes, sir.
Okay. So cos 180 is minus 1. Whenever you have anti-parallel vectors and you do the dot product between both, you'll get a negative value. And the important question is, what if they are perpendicular to each other? Then the dot product will be a 0. So in most of the questions, they will say, find whether the given vectors are perpendicular or not. What will be the test you can run?
If it is 0.
You just do the dot product between them. If that comes out to be a 0, then you say they are perpendicular, else they are not.
Okay.
Okay. So having said this, we can extend the concept to the orthogonal unit vectors. If I do the dot product between I cap and I cap, I'll get 1. Why is it so? Because I cap dot I cap means magnitude of I cap into magnitude of I cap. What is the angle between I cap and I cap? It is 0 degree.
0.
That is why cos 0, which is going to be 1 into 1 into 1, which is a 1. Whereas if you do the dot product between two different orthogonal unit vectors, orthogonal means they are perpendicular to each other. What is the condition for perpendicularity state? The dot product between them is going to be 0. So that is why I dot j is 0, j dot k is 0, k dot I is 0. Dot product between any two perpendicular vectors is always a 0. Okay. So I'll stop with this for today. Next class, I'll discuss the different properties. And for this part, right, for vector product, I think I have recorded. See, for these also, I have recorded videos. I'll send it to you today. You can have a look at it and, have a detailed look through it and then come to the next class so that we can save time on the concepts. We'll solve more of problems tomorrow so that we can complete vectors. Throughout the next week, right, I'll give you some problems for you to practice in the assignments. Okay. So the vector product alone, I want you to go through the concepts and come. The remaining, I'll explain it. Maybe it will take half an hour for me to explain the concepts. Remaining 45 minutes to 1 hour, we'll solve the problems. Okay. So is it clear? Okay. So I'll see you all tomorrow. Okay. Shall we wind up?